Okay, so we're going to look at particular types of sequences now. So the first one we're going to look at is called an arithmetic sequence. Okay, so an example here, 2, 4, 6, 8, is an arithmetic sequence. And an arithmetic sequence is one where the first difference is common. The first difference is what we had looked at in the previous video. It's the difference between each of the terms in the sequence. Okay, so if we look at this one here, the difference between 2 and 4 is 2, the difference between 4 and 6 is 2, the difference between 6 and 8 is 2, the difference between 8 and 10 is 2. Okay, so it has a common difference. That first difference is the same for each of the terms. So it's going up by the same amount each time, so we say that it's an arithmetic sequence. For an arithmetic sequence, we call the first term A. Okay, so the first term, so that's T1. So T1 is called A, okay, or in terms of the formula we're going to look at, the value of A is the first term is T1. The common difference then is D, and you can think of that as being any term minus the previous term. So if we're writing that kind of with our letters, it would really be Tn minus Tn minus 1. So what that means, I suppose, is that if we have, say, T3 and we take away T2, that should be the same as maybe, say, T4, take away T3. The difference between each of these terms should be the same, because it should be common, because it's arithmetic. And for an arithmetic sequence, we have a formula to find the nth term. Remember, we looked at this in the previous part. So this is your nth term, or sometimes it's called the general term. Okay, so to find the nth term, Tn, we use this formula A plus n minus 1d, where A is the first term and d is our common difference between each term. And it's important with this formula is in your log tables, and it also gives you the definition of A and D. So you don't actually need, you should know them, but if you were to forget, they're all in the log tables as well as the definition of each of the letters. What's important with this is that this is your general formula for finding Tn. So this is nearly like a recipe to find Tn for specific formulas. And obviously when we use different values of A and D, then we get a different overall answer. So the answer we get is Tn for the particular sequence that we're looking at. And we can see how that works in this example here. So in an arithmetic sequence, 3, 8, 13, find A, D, Tn, and T20. So let's have a look. So A, if we remember, is the first term. So the first term in this sequence is just 3. So that's fairly straightforward. D then is the common difference. The common difference between each of these terms, if we have a look at it, 3 to 8 we go up 5, 8 to 13 again we go up 5. The common difference then is going to be 5. To find Tn, we'll use that new formula. So A plus n minus 1d. Okay, where A is the first term, which we've already said is 3. N minus 1 we have there enough. D then is the common difference, that's going to be 5. Following through, 3 plus 5, n minus 5. So we're multiplying that 5, even though it's at the end instead of maybe where we're used to it, like this here. Even though it's at the end of it, that's okay. We can still multiply it out in the same way. And then tidying up a little bit, maybe putting the n first, 5n minus 2. So what this means is that for this formula here, for this pattern, this sequence, this is our general formula to find any of the terms. So the first, second, third, whatever the value of n we want, we can use this formula to find it. And that's what they've asked us to do in the last part, is to find T20. So again, noting here that the 20 there is where we normally have n. So we're subbing in 20 instead of n. So 5 times 20 minus 2, we get 100 minus 2, which is 98 as our answer for term 20 in that sequence. Okay, very important that we're able to kind of follow through with all of these sequences here and finding Tn and then subbing it in. Same thing coming up in this second example here. So find the nth term, what term is 97, and show that 168 is not a term. So let's focus on the first bits. Find the nth term. To find the nth term, we need to look at the difference between each of the terms. And we can see that what's happening here is that we're going up in 3s each time. So D is going to be 3. A is the first term, which is 7. My formula is Tn is A plus n minus 1 times D. subbing in for a and d. So a is 7, d is 3, and following it through, 7 plus 3n minus 3, 3n plus 4. So tn is 3n plus 4. Okay, then they've asked us which term is 97. Okay, we have to just be careful and make sure we're happy with what we're being asked here. Which term is 97? What we're looking for here is that we're looking for the value of n. So we're saying, what we're being told is tn is equal to 97. So for some value in our sequence, one of our terms, the answer is 97. What we need to do is we take our tn formula, 3n plus 4, and we put it equal to 97. So 3n is equal to 93, and n then is 31. So what that means is the 31st term in the sequence has a value of 97. For part 3, we need to show that 168 is not a term of the sequence. So again, we'll approach it the same way. Tn is equal to 168. So 3n plus 4 is equal to 168. 3n is 164. And we get then that n is 164 divided by 3. Okay, if we try that on our calculator, what we'll find is that we don't get a nice even number. Okay, n ends up being goes in, well, 3 goes into 16 5 times, and then we get maybe some kind of 5.4 or 54.3-ish. So we're getting that 3 does not divide in evenly. Okay, it doesn't break down to be a nice even number for us. And we should know that n has to be a natural number. Okay, we can't even have the 7.5 term. Okay, we can't have the 8.3 term. Okay, all of our term numbers, all of those values for n are all natural numbers. So we have the first, the second, the third, the fourth. So if we don't get a value of n that's a natural number, then what that means is that 164 is not in the sequence. Okay? If n is not a nice natural number, then that number that we're talking about must not be in the sequence. So that's how we can test whether a number is in the sequence or not. Something that we should see that might come up with these sort of questions is finding the values of a and d. So sometimes we'll be given two terms and we can use them then to find a and d. And this was particularly when we're not given the first term. Okay, if we're not given the first term, or if we're not given two terms that come after each other. Because remember that we already know that a is the first term, so a is t1, and then d is the difference between two terms. But it has to be two terms that are coming straight after each other, what we'd call consecutive terms. So tn minus 1, so like t3 minus t2, or t9 minus t8. If we look at this example here and how this kind of works, we have t4 and we have t9. So that's kind of what we've drawn out at the top here. We have t4 is 11, we have t9 is 21. Those terms are not coming straight after each other, and neither do we have the first term in the sequence. Okay, so that's what we need to work on. So in order to do this, all that we can do is take our formula that we have, sub in the values that we do have, and then go from there. Okay, we can't do any more than that. So we can sub in what we know, and we can see then where that's going to take us. What we should be thinking at this point is that we have a that we don't know, and we don't know what d is either. And generally for a question where we have two things that we don't know, two unknowns, what that should make us think of is simultaneous equations. Okay, simultaneous equations are generally those equations where we had maybe x and y. We were trying to find out what both of them were, and we had to do a simultaneous equation. Here we have two unknowns, so that should make us think simultaneous equations. But we will see how this works out. So taking our formula up in the top corner here, let's try t4. Okay, a plus 4 minus 1 d, and the answer is 11. Okay, that's coming from here. So we know that the answer is 11. T4, the fourth term, is 11. So a plus 3d should be equal to 11. Similarly for T9, a plus 9 minus 1d should be equal to 21. So a plus 8d should be 21. So what we have now are our two simultaneous equations here. So a plus 3d equals 11 and a plus 8d equals 21. And we can write those as we would our simultaneous equations, so one on top of the other. The first thing we want to do is we want to eliminate one of the variables. So we want to get rid of one of these letters. So we'll take one of the equations and we'll multiply it by minus 1 here. And by doing that, what it means is that I now have minus a minus 3d equals minus 11, and I have a plus 8d equals 21. Simplifying that then, that gives me a total of 5d, and it gives me equal to 10, so d is equal to 2. And that's our answer for d then. Then to find out what a is, we sub back in. A plus 3d is equal to 11. A plus 3 times 2 is equal to 11. A plus 6 is equal to 11. So a is equal to 5. So those are our values for a and d. We maybe just write out Tn. So Tn then is going to be a plus n minus 1d. So it's going to be 5 plus n minus 1, 2, which is 5 plus 2n minus 2, which gives me 2n plus 3 as my kind of overall answer for Tn. And then the last part of the question says, hence, find T50. So we simply take our formula from here. Looking for T50, we sub in for n. Okay, and we get a value of 103 as our answer. Okay. Key thing there is that we're looking for both a and d. So we kind of said at the start that's probably going to lead to a simultaneous equation. But if we're even unsure of that, all that we can do is take the information that we have, sub that in and see where it leads us. So if we were in an exam situation here, all that we could do would be take T4, try and sub that into our formula, put it equal to 11 and see where that takes us. And even if we just got those first two lines, we have made a start on the question. The idea would be that once you've got to this point with those two lines, that you would recognize then that that's going to be a simultaneous equation and solve it appropriately then.